So we're going to continue to talk about finance, in particular savings. The first thing we're going to do, we have a couple of objectives. The first one that I'm going to talk about in this video is simply how we're going to use the Excel functions, in particular the FV and the effect function, in order to determine what we were doing with Excel spreadsheets last time. So to determine the future value of some investments, and also to determine what the annual percentage yield is, where before we did that as a percent change in the amount we earned over the course of a year. So we're going to do the shortcut functions, the Excel functions. I will still ask you sometimes to set up spreadsheets, so you do need to be able to do both. But the content here will be similar content as the last section, at least for this video. And we're just going to be doing it in a quicker, easier way using a little shortcut function in Excel. All right, so suppose example one, $1,000, we're going to invest at an APR of 4% and interest is compounded quarterly. We want to determine what we will have after 5 years. So this is an exact one that we did in the last video, and we set it up with an Excel spreadsheet. So this time we're going to use the FV function. So just go to any empty cell in Excel and hit equals. And then you're going to go to the little fx, and that's where we insert a function. So right here, that little fx. And then there's a lot of ways you can get there. If you want to use a drop-down category of financial, this is now our financial unit. And then you can go down and just either arrow down until you get to FV, or if you tap somewhere in these listings and just hit F, it'll take you down to the Fs. So anyway, here's FV. Read what it does. It returns the future value of an investment, and that's essentially what we want to do here, given a lot of different inputs that we can decide on. So FV is the function we want. So rate, again, read what this is telling you. It says it's the interest rate per period. They even give us a nice little example. They say, for example, use 6% divided by 4 for quarterly payments at a 6% APR. So this is the exact thing we had to remember when we were modeling this in Excel. So our rate in this example is 4%. That's probably our initial instinct, is to say 4%. Or 0.04. Notice Excel, again, it knows what a percent is, and so it's already converted that. But it is reminding me here that I have to divide by, and this is a quarterly situation, so I also need to divide by 4, the number of compoundings per year. All right, next box, any box in bold requires me to put in something. Let's continue. N per. Well, what is that? It's the total number of payment periods in the investment. Oh, okay. So when we think about this one, we have, what are we doing? We're doing 5 years, but how many times are we going to be getting paid? We're going to be getting paid payments. We're going to be getting our interest paid to us 4 times in each of those years. So obviously 4 times 5 is 20. That's the exact thing that we had to think about when we extended our spreadsheet. How far do we have to go? So this little shortcut formula in Excel, this function still makes us think about the same things. You could also, if you're dealing with larger numbers and the arithmetic you're not sure, then just make Excel do the multiplication. 4 times 5, 4 compoundings per year times 5 years. All right, PMT. What is that? This is the payment made each period, and it cannot change. Okay, so these periods that we're talking about in a situation where we're compounding quarterly, that would be as if I was putting away money every quarter, but I'm not doing that here. So I'm not making a periodic regular payment. So I don't have anything happening each period. That needs to be a 0 here. But when we go down to this PV box, that is the present value. I'm not crazy about that terminology. I'd say focus on this vocab, lump sum amount. That's the lump sum we're putting in. So in my class, I'm going to give you always kind of one of 2 different scenarios. Either just a lump sum we're going to put in and watch it grow, which is what we're doing here, a lump sum of 1,000 with no regular payments, Or what we'll get to later is we'll look at maybe not having a lump sum amount, but instead putting away, $100 every month or something like that. So here we have no regular payment happening. Instead, we have this lump sum payment. And the type box you can ignore. It has to do with the timing of when the payment occurs, and that's not going to really vary anything too much. We're just not going to worry about that at all. So we're just going to hit OK. And so here we have 12,000, not 12,000, sorry, 1,200. $1,220.19. And so if you remember, that is exactly what we got when we set it up with the spreadsheet in the last video. One thing I want you to be super cautious about, and I don't know if you noticed, but here if you look back in the notes, I didn't highlight it when I had it up in Excel, but there is down here in this formula box, there was a negative there. And that is reflected by the red value. There's a phrase like if a company's in the red, it's in the negative. I call it a quirk in Excel. I don't know, I don't have a good reason. I don't know exactly why. I should find out every semester I teach this. We're saving. I don't know why it kind of comes back in the red or as a negative value, but it does. So you need to be careful if you were to, let's say you wanted to add or subtract, if you were going to try to figure out, well, how much did I make in interest, let's say, and I wanted to look at that, $1,220.19 minus my initial investment of, what was that, 1,000. That would tell me if I just type it in how much I made. I would have to be really careful. I can't just cell reference this number and say, oh, subtract 1,000, because it just added up two negatives. And so if I'm not careful about that, I could really have, some real strange things happen. So just be cautious there. All right, but that's cool. We were able to do this without having to set up the whole spreadsheet. Okay, let's look at another one. And this is one from the previous group activity, but you would have had to have set it up with a spreadsheet. Here we're going to do it with the quickie Excel function. All right, so on this one, delete those. All right, so here it says, suppose that you've deposited $500 in a bank that offers an APR of 6%, this time compounded monthly. How much will you have in 10 years? So again, go to any empty cell, equals. Now, since we've just used this function, it's in your recently used functions. So over here on the left, there's a drop down of recently used functions. Of course, the one at the very top is the one that we just used, which is the future value function. All right, so again, my rate is either 6 with a percent sign, or if you'd like to just do the decimal yourself, either way, 0.06. But I have to be careful here. Again, use the little built-in reminder at the bottom. It's reminding you, oh yeah, per period. Like if it's quarterly, I have to divide by 4. In this case, it was, looking back on the example, it's monthly. So if we are compounding monthly, I have to know to divide by 12. And now, so that tells me they're basically giving me 0.5% every month. N per, well, what's that? Total number of payment periods. This is basically how far you extend your spreadsheet. So when you think about, well, you were doing it 10 years times 12 months in a year. That's how many times you're getting paid with some interest. So the total number of periods here is 120. Payments, okay? This is the payment made each period. I'm not putting away, in this example, I'm not putting away $500 every month. So I don't have a regular payment at all in this situation. Again, for me, I'm going to give you one or the other eventually when we get into those scenarios. Right now, we're just at this lump sum amount idea. Put it in and let it grow. And so in this case, the lump sum amount is the 500. Now here again, notice that little negative. I'm not crazy about it. I wish it was different, but that's just how Excel is. And then you hit OK, and it comes out as a red, and that's technically a negative number in Excel. But here's what we know. That is the amount we have in 10 years. So in 10 years, we would have 909.70. So that's how you can use the FV function and not have to set up a spreadsheet. So the FV will give you the future amount, future value. So another computation I was asking you to do last time was the APY, so the percent you actually yield over 1 year. And so last time we were looking at it as a new minus old over the course of 1 year. So the change in value over original value over 1 year. Now we're going to use a shortcut formula. So we had this scenario last time. We were deciding between two different accounts, and the first account had an APY of 6.05%, so that's its APY, the end of story. But this second account that we were looking at had an APR of 6%, and interest was compounded monthly. So together, that information told us that the APY was going to be, so using this, we knew that our APY was going to be a little higher than 6%, but we didn't know exactly how much higher and how that would compare to the APY of the first account, which was, again, the 6.05%. So last time we modeled it in Excel to figure out what the APY of this second account would be. This time we're going to use an Excel function called the effect function. So if you remember, nominal rate is another phrase for the APR. The effective rate is another phrase, vocab for the APY. So we go to an empty cell, hit equals, go to your little FX up here. And again, you're in financial, and so you can either just scroll down or just tap in here and type the letter E, but you want to get down to the effect, and it says it returns the effective annual interest rate. That's what we want. So 2 boxes that have to be filled in. Nominal rate, remember that's just your APR. Notice on this one, it doesn't say per period, so get used to reading these clues, just nominal rate. So the nominal interest rate in this situation is 6%. So again, either 0.06, or if you're just more comfortable doing 6%, that's okay. N per Y, let's read what that is. This is where we're going to enter the number of compounding periods per year. So in this situation, we are compounding monthly. So that is going to be 12 compoundings per year. And so we're going to hit OK. And just like when we do our new minus old over old, we get the decimal form first. Same thing here. Interest rates, I always want kind of all semester. I've always emphasized percents, whatever, to 2 decimal places. So let's just stay consistent with that. So here we get the same thing that we got last time. It's a 6.17% here. So once again, same conclusion. We're going to choose the second option because it has a higher APY. All right, so that's kind of a short little video. We're going to end this one. Next time we're going to come back and we're going to start to look at how can I plan for a goal. So we're going to look at a new process. We'll do some trial and error, and then we'll look at a more efficient way that how can I plan for a goal in Excel in terms of if I wanted to, be able to have a certain amount in 5 years or something like that. So that's the end of this one, and we'll see you next time.